Hi, everyone. So far, we have 4 key points on the graph. The vertex, or turning point, 3, negative 4. We have the x-intercepts at 1, 0, and at 5, 0. And we have the y-intercept at 0, 5. By the way, from 0, 5, can you see how we can get a 5th point for free by using what principle? The S word. I'll give you a hint. Here's x equals 3. That's the axis of what? It's the axis of symmetry. 0, 5 is 3 units to the left of that purple axis. Notice that if we walk 3 units further to the right, 6, 5 will also be on the parabola, and we get that 5th point for free by symmetry. On top of that, you can do some more point plotting. For example, if you plug in x equals 2, it turns out that 2, negative 3 is also a point on the graph. Therefore, by symmetry, 4, negative 3 is also a point on the graph. So you can do a bunch of point plotting. Again, we're lucky because these were all integer coordinates. But even without those 2 last points, with these 5 points alone, we can get a very good sense of what this parabola looks like. I'll erase the axis even. Well, let's keep the axis in, actually. So you should be able to do a good freehand graph of the parabola. And you would probably get something like that. Very good. Now, speaking of symmetry, I'd like to talk now about the 2 x-intercepts over here, the 1, 0 and the 5, 0. I'd like to talk about these 2 x-intercepts. Notice that the axis of symmetry is right in the middle between these 2 x-intercepts. And what special point lies on the axis? The vertex. Notice that the x-coordinate of the vertex, 3, the x-coordinate of the vertex, 3, which is the x-coordinate for this axis, is the average of the x-coordinates for the 2 x-intercepts, 1 and 5. 3 is the average of 1 and 5, and that's not a coincidence. Why is it that the x-coordinate of the parabola, h, why is it given by this formula, the opposite of b over 2a? Well, that came from what special formula? The quadratic formula. Right. The zeros of the function are given by the quadratic formula, the QF. Now notice that if you take a look at this formula, there are 2 cases, a plus case and a minus case. Let's go back to the parabola over here. Now, when we found the 2 x-intercepts, what did we do? We set the function rule equal to 0. We did that up here. We set the function rule equal to 0. Now, up here we used factoring, but another way we could have done it is to use the QF, the quadratic formula. We could have used the QF to solve this equation for x, and we would have gotten x equals 5 and also x equals 1. So the deal is that the quadratic formula gives us 2 cases, a plus case and a minus case. One case would give us 1, the other case would give us 5. What's the average of 1 and 5? It is 3, the x-coordinate of the vertex. What's the average of these 2 results, the plus case and the minus case from the QF? The average case is given by the opposite of b over 2a. Basically, to get the average of the plus case and the minus case, you destroy this piece of the quadratic formula. So the average of the plus case and the minus case is given by the opposite of b over 2a, just as the average of 1 and 5, the zeros of the function, that average is given by 3. So visually, it makes sense that the x-coordinate of the vertex, which is 3 here, I'll do this in purple, the x-coordinate of the vertex, which is 3 here, is given by the average of the numbers corresponding to the x-intercepts, 1 and 5. That's because the opposite of b over 2a is the average of the plus case and the minus case from the QF. Now, if there's just one x-intercept, well, great. The vertex is the x-intercept. So the discriminant is 0, right? And this part would drop off anyway. So the opposite of b over 2a, that would give the x-intercept and the x-coordinate of the vertex, h. But the funny thing is that even for a flying parabola, it turns out that the opposite of b over 2a will give the x-coordinate of the vertex even in that case, although it's not as easy to visualize why that's the case. But at this point, you should see why it makes sense that the opposite of b over 2a is the formula for h, the x-coordinate of the vertex. It's the average of the x-intercepts if they're real. But see, it's the case even if they're not real. All right. Next up, what is another way that we can find the vertex?